Hello everyone. Good morning. First of all, I wish you very happy monsoon to all of you. I know it's a very good atmosphere outside there and you have a very feeling of newness around you, isn't it? Normally at this in this atmosphere we have a habit of going to school and then new teachers, new classroom, new books, new friends, everything new around us. But of course, unfortunately, this year that is not happening. But the feeling of newness is still there in our heart, isn't it? So when we see outside atmosphere, we always feel like to do all that. What actually now we are missing. When we used to go to the school, we used to get bored with the school. But now we realize the exact meaning of the school, why school is important to us. Isn't it? You all are missing the school right now, isn't it? Missing your friends, missing that enjoyment, and missing everything, all that. Okay, but still, nevertheless, we have school is going on, but in a different way, in a different manner. Even that is new to us, new for us. So let us enjoy all that with the very new topic of science, that is matter in our surrounding. Okay, so it's a very simple topic. It's a very first topic of your chemistry. It's a part of the chemistry. It's a very first topic of our chemistry. Let us understand what exactly the topic is. It's a topic which we are studying from your, small grades. Okay, so only thing is that few different words we will be hearing in this topic, and that's it. It's a very simple approach. Okay, so let's start. Normally when I take science, we don't go with very heavy explanation. We finish it early because I know that whenever it is a science, however I explain, you have to remember a few concepts to write the answer in the examination. So it's better that early we complete and we start remembering, we work on questions and answers. All that we will work on instead of wasting our time in unnecessary explanation. Okay, so let's start matter in our surrounding. Today I'll be showing you some activities as well. So be there, be energetic. The session is going to be enjoyable. Okay, so let's get started. Matter. Matter, what exactly the matter is? Whatever you see around, or sometime what you cannot even see, can be the matter. Now, for an example, a stone is a matter which you can see, and air is a matter which you cannot see, right? So, matter is something that what it will occupy the space that needs space is nothing but called as a matter. Okay, so anything which need space and of course mass, it has got a weight, we call it as matter. So in case of air, it has got some mass as well as it takes some space around you, we call air as a matter. Liquid, matter. Solid, as a matter. Stone, sugar, salt. Yourself, no, yourself, you are not a matter. You're organic matter. Okay, so let us not consider about organic matter. In this topic, we are working on inorganic matter only. Organic matter will be working later on in the biology part. Okay, so today we are just working on inorganic matter. So whatever is we see around us which takes some space and mass is called as a matter. So there are some examples of matter. There are so many different category of examples are taken here, which you all can easily see, which you can easily read. Okay, then matter is so wide around us, wide in sense, wide in range. There are so many things around us. So it was a necessity that we need to classify the matter. We need to know to classify the matter. So in ancient time in India, we used to classify the matter, or we used to think that everything is made up of five tattva. Okay, air, fire, water, earth, and sky. Okay, Panchatattva. We used to call it as Panchatattva. So whatever is there around us is made up of these five tattva. Okay. So many Indian philosophers used to say that nowadays there are so many channels like showing Mahabharata or Ramayana on the TV. Or over there you must have heard about this Panchatattva word. Okay. Uh, so classification of matter in ancient time, like from Indian philosophers or all over the world, many philosophers had suggested some classification of matter, but of course, when time passes, it was proven that it is not the way to classify the matter. The later on in modern science, we classify the matter into two ways. One by using its physical properties and one by using its chemical properties. So in this particular topic we are just working on physical properties, that is solid, liquid and gases. In the next topic we will be working on based on its chemical properties. So chemical property, just keep it aside. Let us talk about in modern science how the matter is classified. The matter is classified in terms of solid, liquid and gases. Okay, so it's a very simple approach, so I don't have to tell you. But matter is not just about saying that whatever is there around us is a matter. We need to understand the matter very properly. Okay, so all the way this topic we are learning to understand the matter somewhat deeper than what we right now know. Okay, so let us understand how is matter made up of? What is it made up of? So let me tell you, the matter around you is made up of small particles, very tiny particles. Everything around you is made up of very tiny particles. If you see your pen, which is a plastic, right? The plastic is made up of very tiny particles, bound together, right? A fan or maybe your any metal is made up of very tiny particles. If you take a chalk in your hand and if you just rub it, you will find those particles separated, right? There are some which you can see the particles separated, but few things the particles cannot be easily separated. But still, each matter is made up of particles, right? Small particles. Even liquid is made up of small particles, very small particles, like water is also made up of very small particles, right? So everything around us, the matter, is made up of particles. Now after this we will believe on this, that everything around us is made up of particles, and these particles are situated. Okay, they are situated, and that what together we call it as a matter. Okay, so let us talk about these particles. So ये particles कैसे हैं? How are they? Can we see them? See these particles? Can you see them? Can you know their properties? All that we will be understanding. So how these particles are? Let us talk about the properties of particles. So let us see here. It is very interesting and important question that what you may get in your very first examination, that to write the characteristics of a particles of matter. So how particles are? Okay, let us discuss one by one. Particles are the matter is made up of very small particle. That means it says that the particles are very small, very small. Each matter, everything around us is made up of particles, and these particles are very small. Okay, how small they are, which you can't even see with your naked eyes, that small they are. Okay, so keep in mind the particles are very tiny, very small. Particles of matter have space between them. That means if I take a glass full of water, I can see the glass full of water is continuous. That means there is no space between any particle I could see. But let me tell you, as these particles are very small, if I increase or zoom it out here, the particles are very small, but still there is a typical space between the particles. Okay, you can see that there is a space between the particles. Can you see that? So it's very clear that always the particle has got a space between them. Okay. Then particle of matter are constantly moving. This is quite interesting, very interesting, and normally it becomes difficult to believe that the particles are moving. In case if I check the air, if I look at the air, isn't it air is moving continuously? Okay, so there I can believe. But if I say that water, if you see in the glass, the particles inside the glass are moving continuously, you will say, what nonsense? How can it move? Okay, but we will have a simple experiment to check, okay, whether they are continuously moving or no, that we can see in short time. So don't worry. So it is moving. So remember that, okay, particles move constantly, and if each particle has got its own kinetic energy depending on the matter, that means whether it is solid or liquid or gases, depending on that they have got their own kinetic energy. Kinetic energy matlab moving energy. Okay, so particles are continuously moving. This motion of the particle has got some name. I think it is called as a Brownian. Yes, Brownian moment. The motion of this particle, they are continuously moving, is called as a Brownian moment. Brownian का मतलब होता है random moment. Okay, so the word थोड़ा सा अलग है, but फिर भी it is nothing but the random moment. That's it, nothing else. Anyway, of course, the last one, particles of matter attract each other. So you need to remember all that. Okay. So when in case if you would have been in front of me, I would have just got it remembered from you. But unfortunately, you're the not there. But remember it. It's a very simple thing. First thing क्या होता है कि particle of matter are very small. Matter is made up of small particles. Okay. Our particles have space between them and they are continuously moving. These three things are very simple and they attract each other. Okay. Particles attract each other. That's the reason you can see them together. That's it. Okay, imagine if you want see if you want to check that okay, particles are attracting each other. If you open the tap of water and if I ask you to cut the water flow, cut the water stream, isn't it is impossible to cut it, right? Because particles are always and always they are together. Okay, they try to be together. That's the reason the liquid flowing you cannot cut, right? The flow of liquid you cannot cut, right? It is because the particles, they always want to be together. And why they want to be together? Because they have a force of attraction between them. That's a very simple idea, very simple idea. Chalo आगे बढ़ते हैं. So here is the activity number 1. You have to put a potassium permanganate in the glass full of water. Okay, so here is the water. You can check that the I'll show you the video as well, but before that I just want you to understand what exactly you're going to observe in the video. So when potassium permanganate is put into the water, we are not actually going to stir it in the beginning. We are just going to allow that particular potassium permanganate to just get dissolved all by itself into the water. But when you see that the potassium permanganate, when it goes down, isn't it, it is giving color to the water. Okay, it is giving color to the water. That means what is exactly happening here, that the potassium permanganate is converting into small particles and it is taking some place between the water. Okay, and that is nothing but giving color to this water. In fact, that color is nothing but particles of potassium permanganate which are taking place between the molecules of, or between the particles of water, right? That's it. Anyway, let us see the video for this. Here we have the video. Okay, did you see the video? What you observed there, that before we stir it, still the particles of this particular potassium permanganate are moving. Did you see that? It is moving in the water, right? This itself, I was just telling you that particles are having its own kinetic energy. The characteristics of the matter or the particles of the matter is they are continuously moving. Did you see the fourth characteristics? The particles of matter are continuously moving. Because of this motion itself, let me tell you, because of this motion itself, the without stirring as well, the potassium permanganate was seen there all over in the water. Okay, so anyway, what we learn from the activity, we observe that the tiny particles are moving in the water on their own. That is a very important part that what one should understand. Those tiny particles of the potassium permanganate are moving on their own. Okay, this proves that the particle has got a what do you say uh, moment. Okay, they move on themselves, continuously moving, and these particles spread evenly after a while in the water, and this is called as a dissolution. When something is dissolved in the water, it's called as a dissolution, right? Anyway, yep, a very very interesting activity, but I'm not actually going to show this activity because I couldn't find it on the YouTube. But still, I can explain you this activity. It is expected that you should take 100 ml of beaker. So I'll just draw for you the 100 ml of beaker and take some water in it. Okay, so here we have the beaker, and there is water put in it. Okay, so here is the water and this is the water level. Okay, now we dissolve some salt or sugar in it. Sugar would be better, right? We dissolve in it. Okay, so sugar is added in this. Now we stir it with this spatula or spoon. Now what exactly we're going to observe in this, that don't you think we expect the water level to rise up a bit when we add something in it, right? When you dissolve something in it, we expect the water level to rise. But believe me, unfortunately, no water level changes. The water level remains same. Now the question is, where this sugar went? Okay, it dissolved in it means what? It is eaten up by the water? No, it has to be there, isn't it? If you drink this water, it will give a sweet taste. That means the sugar did not go anywhere. It is still there in the water, right? But water level is not increased. Now, why this has happened? Why this has happened, isn't it? So this is a very interesting reason. Let me tell you what has happened is that these are the particles of what do you say water in case, and sugar takes place between the particles. As we all know that the particle has got a space between them, it is a characteristic of matter, then that space is been occupied by particles of sugar, right? So simple reason here is that sugar is not disappeared from there. The sugar is still there, but it is taking a place between the particles. So the characteristics that what we have seen before, all those characteristics we are checking in this manner, okay, by the activity. So what we learn from the activity, we observe that the sugar or the salt maybe disappear or dissolved in the water. Even after addition of extra salt, the water there is no change in the water level. Okay, so even after adding the sugar or salt in it, there is no change in the water level. This is due to particle structure of matter. I mean to say, this is due to particle structure of matter. And salt crystals separate into very tiny particles and go into the space between the particles of water. That's what we have discussed just now. The activity verifies that the particle structure of a matter and the space between the particle we can easily see. Okay, so we can easily verify here that the structure or the matter is made up of tiny particles and there is a space between the particles, right? Got it? Okay, now this is the activity number 3. This also will check. This proves that the particle is very tiny, very very tiny, and there are thousands of particles or rather lakhs of particles available in spoon, just in a simple small spoon of any kind of a spoonful of matter. Okay, so this is the activity number 3. Let us check the activity as well. So here is that activity.
Matter is composed of small particles, but how small are these particles? Let us try to understand this through an activity. We need some potassium permanganate and 6 glasses filled with water. Add a few crystals of potassium permanganate in the first glass. Stir it well. We We can see that potassium permanganate has given color to the water. Now put 40 milliliters of this colored water and put it in the second glass. We can see that even the second glass has got colored, though to a lesser extent. Similarly, continue adding equal volume of water from the preceding glass to the next one. If you see the glasses now, you will see that few potassium permanganate crystals were able to give color to a large amount of water. This is because potassium permanganate breaks down to individual particles when dissolved in water, and the fact that these particles can be distributed in large volumes shows that there must be multitudinous particles in the small amount of potassium permanganate crystals that were taken.
Okay, you must have understood what exactly inference, that means what exactly we can conclude from that particular experiment, that every time we are diluting the potassium permanganate solution, right, diluting, even after diluting potassium permanganate solution, it is giving color to every next glass of water as well. That means what? That means what? A small spoon, a very small spoon, very less number of potassium permanganate could give color to all the large volume that what you could see there in the particular beakers, right? That means the potassium permanganate is not just in that particular spoon, but these are very small crystals, and n number of particles are available in that particular small the spoon full of potassium permanganate. Okay, so this proves that this activity proves that a particle is made up of very particle size is very small. Okay, so you can check what we learned from the activity. You can read it properly because I'm sending this PDF to you. Don't worry, PDF is already I'm sending. Okay, activity number 4. It's a very simple activity. If you uh, leave the essence stick at the corner of your class, isn't it easily the one person who is standing outside the class also can smell the perfume, the essence of that particular stick, isn't it? This is why it happens, because the essence, that means the perfume present in that particular stick, essence stick, uh, moves with the air. Okay, it is actually dissolves in the air, and dissolution, these particular perfume or the particles of perfume, that smell, the particles of smell entering or mixing with the air, and it move continuously, that goes on continuously moving, right? And it quickly reaches to the person who is standing outside the class. Quickly it reaches to the person. So you can see how fast the moment is. Even your mother cooking in the kitchen, you can easily sense sitting in the hall. So you can understand how fast the smell reaches to you through the air, and it doesn't reach like someone is forcing it to reach to you. It is in fact has got its own moment, and it moves on their own. So this proves that every particle move on its own. Okay, and they have their own motion. Okay, yeah, I hope you understand. So we observe that the incense stick burning at the one corner, and its fragrance spread in the whole room quickly. The particle produced by the burning of incense stick move rapidly in the room on its own. That's important. It moves on its own. It mixes with the air in the room and reaches to us very quickly. And this is due to diffusion of gases. Let us understand the word meaning diffusion. ये diffusion क्या है concept? Let me tell you, diffusion is like moving from higher concentration to lower concentration. Okay, कैसे होता है? I'll tell you. See, if we throw carbon dioxide from our nose in the air, right? Okay, so carbon dioxide reaches to the air and it don't remain there. Okay, if unfortunately that would have been remain there itself, we would have felt very much suffocating, right? It doesn't remain there, rather it quickly moves away from there, because the air around your nose become higher concentration with carbon dioxide. So what happens, carbon dioxide quickly flow with the lower concentration that is in the atmosphere. Okay, so it's a very simple idea, very simple idea. Every matter move from a higher concentration to lower concentration of itself. Okay, so diffusion is a very important process through which all our activities are in fact happening. All our internal body activities are happening. Okay, the gases exchange, that what we do, it is nothing but due to diffusion. So what is diffusion? Diffusion is moving or motion of a particle from higher concentration to lower concentration. ओके मतलब जहाँ पे ज़्यादा होता है वहाँ से जहाँ कम होता है वहाँ पे वो मूव होने लगता है, एंड दिस इज कॉल्ड एज अ डिफ्यूजन. It is nothing but called as diffusion. Idea clear? You got the concept? Hope you are getting it. For this, if I tell you a simple experiment, I'll tell you what I'm going to do. See, I have a glass here, and this glass is connected with another glass with a simple straw. Okay, seal है, and I feel the water in it. So quickly water will go into this. So it's very simple. The water level in the both the glasses will be same. Now if I dissolve salt in it, in the first glass, so in the first glass if I dissolve salt and stir it properly, so what do you think? This water will not be salty, or it will be salty? Okay, I dissolved the salt in this particular water and I did not make any change in the second glass. This is still remain as it is without the salt. So what do you think, that this water will be salty? Yes, it will be salty. Why so? The water here has got salt in it and here no salt in it. So the salt particle here has got a higher concentration and here the salt particle has got a lower concentration. So salt will move from higher concentration to the lower concentration quickly, and quickly within no time you will find that even glass 2 will have a salty water in it. Okay, so this is due to diffusion. This is nothing but due to diffusion. It is called as a diffusion from higher concentration to the lower concentration. ठीक है, चलो आगे बढ़ते. Now this is another experiment for a hot and cold. That means this is actually to prove that a dissolution, or you can say diffusion, happens in cold water or cold atmosphere is larger extent, or in hot it is larger. That means diffusion or maybe dissolution is larger where? In hot atmosphere or in cold atmosphere? You tell me, what do you guess? In hot it will be larger diffusion, or in cold it will be larger diffusion? No idea? Okay, let's watch the activity then. Okay, so you must have observed that where it was hot water, the diffusion or dissolution was quite faster. Okay, this is due to temperature increases the motion of the particle. Remember, every matter has got a particle and every particle has got its own moment. Okay, so temperature increases the kinetic energy of the particle. Kinetic energy matlab moving capacity. So the temperature increases the kinetic energy of the matter, and that's the reason in hot water the dissolution is faster than the cold water. Okay, that's the reason. That's the reason. If your food is hot, you can easily take a smell of it. You can easily get the smell of it without going near it. But in case if your food is cold, you have to go near it to taste it, to smell it. Sorry, you have to go near it to smell it. The reason why it is so, because temperature increases the kinetic energy of the particle, and those particles can easily move around, right? Whereas low temperature will not allow the particles to move, or it will reduces the kinetic energy of the particles, and accordingly you cannot quickly get the smell of it, right? So anyway, copper sulfate, or we use same potassium permanganate in the activity. Here it is said the copper sulfate. Copper sulfate is blue in color. That's why it is so seen blue color there, and potassium permanganate is red in color. Anyway, so points to remember: particles of matter are continuously moving. They possess, matlab they possess kinetic energy. Due to increase in the temperature of kinetic energy, the kinetic energy of the particle also increases. When temperature increases, the kinetic energy of the particle also increases. Oh, here it is the Brownian motion. As I just now told you, the motion of the particles is nothing but called as a Brownian moment. The moment of small particles suspended in the liquid or the gas called as a Brownian moment. Okay, so we have discussed this, isn't it? So when we see the dust particles in the air in a sunlight, the dust particles are continuously moving. We don't find them settling down, right? It is continuously moving or suspended or hanged in the air. We call that is nothing but Brownian moment. Okay, random moment. Anyway, so there are so many different examples now to know what do you say characteristics of matter. Okay, so here we have take a nail, iron nail, and a piece of a chalk and a rubber band. Try to break them. Okay, by hammering or by cutting or by stretching. In which of the above three substances do you think the particles are held together with a greater force? Okay, so don't you think nail has got a particles held together very strongly? Okay, then rubber, it is with the less, and chalk it is lowest, right? Similarly, however, the particles are held together, but still they have got a force of attraction. Okay, so open the water tap, try to break the stream of the water with your finger. So do you able to cut the stream of the water? No. Why we are not able to cut the stream of the water? The reason is there is a force of attraction between the particles. What is the reason behind stream of water remaining together? Yes, force of attraction. That's it. Okay, that's it for today. We are supposed to answer this question. Uh, that's it. So this four question I want from you. So you will complete this four question and send the pic to me. Okay. Which of the following are matter? Chair, air, love. Love is not a matter, right? Smell is not a matter. Hate, not a matter. Almonds, yes, matter. Thought, not a matter. Cold, not a matter. Cold drink, yes, it is a matter. Smell of perfume, yes, it is a matter. So you will say now, okay, smell is a not a matter, but smell of perfume is a matter. Let me tell you, smell is a sense, and smell of perfume is a sense due to perfume's particles. That's why we say it is a matter. Anyway, give reason for the following observation. Smell of hot sizzling food reaches to you several meters away, but to get a smell from a cold food, you have to go close to it. This is due to temperature. Temperature increases the motion of the particles. So that's the reason hot food, as the temperature is quite higher, the particles quickly move and reaches to you. Okay. So simple reason, temperature increases the motion of the particle. That's it. A diver is able to cut through the water in the swimming pool. Which property of matter does this observation show? I think Oh, the water is made up of particle itself is enough here. Okay, so water is made up of particle. That's the reason water diver can easily separate the food particles and jump or cut that particular water and quickly enter into the pool. Anyway, so what the observation here we can see, it is particles are made up of matter. What are the characteristics of particles of matter? You have got all that characteristic of matter in the beginning itself listed above there. Okay, so you can easily write that. So you can write these four answers properly and send it to me. Till then, bye bye. See you tomorrow. Tomorrow we are going to complete this topic. Almost we are going to finish this off. Okay, so bye bye. I hope you all are enjoying. See you tomorrow.